How to establish mates. I think we should break up. Wait, hear me out. I know just the tool. Think of mates as creating connections between different parts in an assembly. Some parts needs to slide through holes, others needs to stay aligned, and some needs to maintain a specific distance or angle. The concept is very similar to geometric relations in the sketches, except instead of controlling 2D sketches, we are controlling how 3D parts move and interact. To use mates, you need two things. 1. The entities you want to connect, and 2. The type of mate relations you want to apply. To get started, select two different edges or faces from two different parts. Sometimes SolidWorks will automatically display a quick mates menu, and you can select the relations from there. Or you can also manually create one by navigating to the Assemblies tab and select Mate. Inside the Mates property manager, mates are separated into 4 different categories. You have the standard, which contains the most common mates type used for everyday assembly. You got the advanced for more specific or complex relationships. The mechanical, which is used for mechanical connections such as gears, cams, and pulley system. And analysis. Most beginners and especially CSAW student won't touch it. So don't worry about this relationship yet. It contains specialized tools that you'll probably use later as you become more advanced. Standard mates are usually enough, but exploring the other options can help you understand what SolidWorks is capable of. For beginners, you'll mostly use coincidence, concentrics, distance, parallel, and angle mates. Depending on the mates you select, you can control how parts interact. Examples include creating a concentric mate between two circular surfaces, or locking a part rotation using mates option, making two faces coincident so they can touch each other, setting a specific distance or angle between surfaces. You can also reverse the mate direction by clicking the Align Flip button. After selecting your mates, SolidWorks will show a preview of the result. If everything looks correct, click the green check mark at the right side of the workspace to confirm the mate. Keep in mind that one mate usually removes 1 or more degree of freedom. Most parts require multiple mates before they become fully constrained. You can continue adding multiple mates while the mate command is still active. To see the part in action and to see if any part is still capable of moving around, just simply click and drag a part around and observe what direction is it moving. Then add more mates to keep the part in place. When you're finished, click the green check mark to exit the feature. What if you made a mistake? No problem. Navigate to the Feature Manager design tree and expand the Mates folder. Find the mates you want to change, then right-click it to either edit or delete the mate. Pay attention to the symbol next to each component in your assembly. They show you the current conditions of your part. The F tab stands for fixed. That component is usually fixed and is locked. It cannot move, but you can make it movable by right-clicking on it and select float. If you see a minus icon, that means it's underdefined. The component still has some remaining degree of freedom. You can drag it to see how is it still able to move. If there's no symbol next to it, it means it's fully defined and the component has enough mates to remove all movement. If you see a plus icon, that means it's overdefined. Conflicting mates has been added, and you may need to edit or remove unnecessary constraint. If you understand geometric relations in a 2D sketch, then mates should feel very similar. Instead of controlling lines and shape, you are now controlling real 3D parts. Master mates, and you can connect almost any assemblies together. Looks like they're happily mated. And now you know.